Time now for this week's Health Matters with me, Paul Critz, along with PA and your host, Lynn Szabo. I don't know why I paused right there. I don't know, for dramatic effect.
I was impressed.
So is today's show is it because of Halloween?
No, not really. It's kind of like an attempt to be a little lighthearted. I started thinking about the pineal gland last Sunday, and I spent like 3 or 4 days trying to figure out why anybody would care about it.
Was there a reason that you started thinking about it?
It just crossed my mind, and I thought, wow. I've never seen any pineal gland pathology.
That's never been something.
I kind of vaguely know where it is. I'm not certain what it does.
Wow.
But,
okay. All right.
There's all kinds of little, mostly vestigial. The pineal gland is not vestigial, but so little leftovers from our evolutionary past that are kind of weird, and you find them on exam occasionally, and you go, wow, that's trippy. You have a Darwin's tubercle, and people go, oh.
I love that. This is like so then it's just this is sort of clickbait for Health Matters then. This is
maybe
kind of the cul-de-sacs and things that are hidden away, just kind of hanging out in your body.
That are kind of random, not really useful, but we still got them. Also, it kind of highlights how things in medicine are named after old deceased mostly white males.
Right.
Yeah.
Like Mr. Peniel?
Yeah. So anyway, I finally did look it up, and actually pineal is named after pine cone because it looks like a pine cone, and it's located in the center of the brain. But it does an important thing. It produces melatonin.
Oh, wow.
So it's kind of in control of our wake-sleep cycle, which is a big deal. And it's also an example of hormones that people don't think of when they say, I just want you to measure all my hormones. Like there's over tens of thousands of possibilities. Here's one of them.
Wow.
Okay.
So melatonin's a hormone.
Yeah.
See, I didn't even know that.
I know. And I'm willing to bet there's a feedback loop that contains some other hormones that I just didn't bother to look up.
Okay, yeah.
So usually when the brain is secreting hormones, at some point there's a feedback loop, like with the thyroid, that will say, okay, stop secreting hormones because, goal achieved. Okay, you can stand down now. And so, in any one feedback loop, there's probably 2 or 3 of them.
Is there?
Hormones.
I remember asking you this, if not last week, then the week before. But is a hormone just like an on-off switch sort of thing, just carrying information, like do this, like regulating functions? Okay.
It's messenger pigeons, what we called it last week. Yeah. Yeah, it's like, do this now. Okay, stop doing this.
Wow.
So it's really important in our wake-sleep cycle, but it has something to do with development of sexual organs and skeletons in children. And
I thought you meant the development of sexual organs and skeletons.
Oh, that's really weird. And they know that because when kids have have damage to the gland, then they go askew in this way. So,
wow. Okay.
Yeah. It changes in appearance as people age, mostly becomes calcified.
Well, that's so much.
And overall, I think it's kind of a mystery. They call it after it's calcified. So we're probably of the age where ours is mostly calcified. It's called the sands of the brain.
The sands of the brain?
Cute. Yeah.
So is that why older people have trouble sleeping? Just
might be.
Oh, wow.
Yeah, it totally might be.
Oh, man. Yeah, I think mine's calcifying. Oh,
yeah. So
I don't like that thought. Thank you. Let's move on.
Yeah, let's move on. That's creepy. So the next one is Darwin's tubercle, and I see these occasionally, and it's a pointed cartilaginous bump on the upper ear. Okay,
like on the outside, you can feel this.
Yeah, along where your terminal ear kind of folds over.
Okay.
And there's a little bump there. It's like somebody put a little ceramic bead under there, and you're touching your ear and kind of mystified about it, but it would be known to you if you had one.
Can I not have one? Is that an option?
Yeah, have one. It would be called common.
Okay, good.
Every once in a while I come across one, and I'll say in the exam room, how cute, you have a Darwin's tubercle. And people don't,
They're like, oh my God, how can you cure it?
What? Is that dangerous? So you have to be careful what you say in the exam room. But this is vestigial, means likely had a reason in the past, but now nobody really knows why.
Wow.
But occasionally people have them and they don't know why.
Is there any sort of like reason that somebody, because I could see being like a student or a researcher or something and just kind of getting this thing for Darwin's tubercle and like spending my career finding out everything I could about it.
Yeah, going on a hot tear about it. Yes. And there are pictures of monkeys that have them.
Wow.
And some cats kind of look like, they don't really have a cartilaginous thing, but they've got little tufts of hair. There's something about, it's like a design point or something. I don't know why.
I wonder why.
I don't know why. But, the cartilage in the external ear is tricky. It doesn't have a great blood supply. That's why it always makes me nervous when people pierce it, because you could really get into trouble with it. So some people already come decorated, I guess.
Yeah, right.
That's the take-home
accessorized.
Lesson. So if you want to win the trivia, it's called a Darwin's tubercle.
Any idea why it's named after Darwin? I assume it's named after that Darwin.
I don't know if it's named after that
Right,
Darwin.
could be a different Darwin.
It could be a different one.
Or the city in Australia.
Yeah, but let's assume it is. So I think it's just a way of saying, oh, this is a vestigial evolutionary thing.
Okay.
And then here's another fun one, auricular muscles. So auricular means ear, and this is kind of related. This is a group of 3 muscles that are around the outer ear, kind of up at the top. Mm-hmm. Okay, so if you were looking at your Darwin's tubercle and you just kept drawing a line up into your scalp, that's where the auricular muscles would be.
Wow, okay.
They exist to move the ear.
Okay. So this has to be vestigial in humans, right?
Yeah, that's totally vestigial. And so in humans, they're largely non-functional, but the muscles are still there.
You can wiggle your ears, sure.
Yeah, I've seen people that can, but I personally can't.
You can't, really?
Yeah.
You got to work on those muscles.
No, not like a dog or a cat would, but people can wiggle their ears, and this is the mechanism for doing it.
Wow.
But, I guess you could consider those people kind of evolutionary leftovers. But I think that's a cool thing. And their ears are a hot topic today, I guess.
Okay, wow.
Preauricular pits. So auricular again means ear. So what this is right where the tragus is. Anybody has a tragal piercing will know what this is. But if you were going to stick your finger in your ear, there's a cartilaginous bump kind of in between your finger and
What's
your
that called again?
That's called a tragus.
A tragus. That's
so
wonderful.
When my daughter said she was going to get a tragal piercing,
no.
I was like, no. Do you know the blood supply is not very good? Anyway. And
so does that mean that's the second time you've mentioned that? Does that mean it could be more prone to infection that way, or can not fight off an infection?
Yeah, piercings gone wrong. I mean, they're really scary when they get like that. And, you could have an amputation, because you have something poorly healed.
Wow.
So don't do it.
I'd have the other one removed too, just so it felt balanced.
Yeah, there you go. So these are cool. They look like a little ding, like a little rock hit your windshield. And they're near the front of the ear, but they're remnants of fish gills.
No way, really?
Yeah,
wow.
That's kind of cool.
That's very cool.
Yeah. Sometimes people will have a little nodule there, so they don't have an innie, like a pit. They have kind of a hard little mass in that area. And that's also brachioclepsis, which is residual fish gills.
Okay.
So very distant, evolutionary speaking.
Well, yeah, evolutionary very distant, but in your own personal life, you had those when you were in the womb, right? Is that what it's left over? That is what it's...
Yeah, exactly.
Wow.
Yeah, it's embryologically developmental. They serve no function. People always try and pick them because they're certain if they can get the pus out, they'll go away. That is a mistake.
Oh, my God.
Yeah, don't do that. They serve no function and never cause a problem unless humans mess with them. So
preocular or auricular pits... is that anything related to like there's some creatures that have like pits like in front of their ears that help like channel sound?
No, it's not a sound thing.
It's not a sound. It's just what's left over from the gills.
It's like a residual, gill
Okay.
thing.
All right.
Probably related to brachial cleft cysts, but I see more preauricular pits than I see brachial cleft cysts. So again, if you comment on it, people are alarmed, but it's no big deal.
Okay, cool.
Okay. So getting away from ears. This one was kind of interesting during the presidential elections of the past. A philtrum. So philtrum, Philtrum, is the vertical groove between the nose and the upper lip.
Wow, okay.
We all have them. We kind of don't pay attention to them. They're only found in mammals, and it's thought to direct smells up into the nasal cavities, so to enhance the sense of smell.
Huh.
But in humans, it has no functional significance. Now, it can have a certain appearance if somebody is exposed to alcohol in utero. So if their mother's drinking alcohol before the baby is born, it can cause the philtrum to have a flat appearance and not that little ridged appearance.
Wow. And that's not it's not like fetal alcohol syndrome or anything. It's just exposed to alcohol.
I think it's a clue to it, but it's not necessarily defining it. And so somebody who's known as, who has a flat philtrum is Bush, the younger Bush.
Really?
Right. And there was all kinds of, during that election, Bush Gore, there was all kinds of speculation in the medical community about what that meant, maybe.
Oh my God.
Yeah, it's kind of sad, but kind of interesting. So, I mean, we watch you guys in the line at Safeway, and you know, sometimes we can get judgy that way, but I don't ever see people that have problems with this, except I suppose a cleft palate or a cleft lip, and I have seen some kids with that in my career.
Yeah.
But that's not because of the philtrum. That's more, it's deeper malformations.
Right.
Yeah. And luckily, we have great care for those kids here.
Do we? Here in Del Norte? What do you mean?
Well, we can get them to great care at UCSF and Children's and stuff like that. So what they're able to do as far as, it's not really cosmetic surgery because it's kind of functional. Those clefts go into the palate, which if you can get a kid to open their mouth and see deeper in, the first time I saw it, I was like alarmed. It's really abnormal and it's complicated to fix.
Sure, I imagine. Yeah.
And can you imagine that kind of surgery on an infant? It's traumatizing for everybody. But they can correct it so that they're barely noticeable.
Wow, yeah.
But think of how you feed a kid like that.
Yeah.
Because they're going to be probably sucking up formula into their nasal cavities, and then the formula comes out their nose unless they have a special bottle.
Oh my God.
It's complicated. But we do have good care at UCSF. And so the next one is the thymus gland. This one is a gland behind the sternum, kind of near the heart. And it really is only important in kids. As we age, by the time we're teenagers, it becomes not as important. So it shrinks and it kind of goes away. But what it does is for children is it makes T cells.
Whoa.
And so T cells are part of the acquired immune system. Okay. So if a child has no thymus or a poorly functioning thymus, they're pretty severely immunodeficient.
Right.
And T cells were kind of the problem in HIV disease, as you may or may not recall. And people who have a lower number of T cells, like those men did, or the ones I work with, mostly men, is they got sick in certain ways. So it was kind of like specific holes in their shield. Does that make any sense? Yeah. And so anybody with a T cell dysfunction or a low number is going to get sick in super predictable ways. And fortunately, our understanding of that is now we can predict those. And as you know, you can bring a kid through childhood, and as they get closer to adolescence, my hope is that becomes less of a problem, but I don't know that for certain.
What happens then after you grow up? How do you make T cells?
Your bone marrow makes them.
Okay.
Unless your bone marrow is affected by disease. So
That's interesting. Are there other structures that start out like super important and then kind of just either it's, the functionality is moved to some other structure
they
later
kind
on?
of peter out. I imagine so. I can't think of any offhand though. But yeah, things that are really important to a kid staying alive, that kind of goes away. Yeah, we evolve over time. That's kind of interesting.
That is interesting. Yeah, I wonder why that is. I wonder what.
Oh, I
what
could
sort
think of something actually offhand. You know the frenulum. You know what a frenulum is?
I've heard the name, but I don't
Okay,
know.
so it's a little flap of tissue. There's a couple of frenulums. One is under the tongue, and one is by like what holds your upper lip to the gum. Between your incisors.
Sure.
Now, those have really important functions in getting a kid to suck normally, right? So how else would an infant eat? I mean, I don't know, a J-tube or something, some kind of artificial medical thing. But those are really important. They have to be the right length and the right elasticity in the right place.
Wow.
So inserted to the gum in the right place, inserted to the inside of the lip in the right place.
Interesting. And then later on, that function isn't near as important.
Yeah, it's not as important at all. And so they clip those in kids, and I would say with newborns, people are kind of obsessed with it. Like anytime a baby has a problem eating, it's got to be a tight frenulum. But I don't think that's the case.
That a common?
I think it's
Okay.
way more complicated.
Yeah.
But fortunately, we have a speech therapist who works with Sutter, and he is able to ascertain if the frenulum is really the problem.
Wow.
Or if the kid has some. I know, isn't that cool for us?
That man.
Yeah, so he works
No,
with,
I mean, yeah, it's cool for us, but just to discover that as
Right.
something to to consider. That's just nuts.
and by the time you can speak and you're not, drinking formula anymore, then
yeah.
who cares what your frenulum's
Here's
doing?
what you say. My frenulum was tight.
Yeah, I wonder if it has something to do with lisping a little bit.
Wow, okay,
Maybe.
okay.
I don't know, but I can't think of any pathology
Yeah.
that somebody who had been born with that situation would age into.
Wow.
Now,
Okay.
if somebody tried piercing it or something, that could be a problem. So don't do that.
There's a pointless piercing.
I think so. But people have piercings are, like, really? You did that, huh? So the next thing after the thymus gland is the plica semilunaris. This is kind of cool. This is a folded tissue in the inner corner of the eye near the tear duct. So first thing, it's cool that somebody figured that out. I mean, I don't know, in medicine, anatomy wasn't something I was super interested in.
Yeah.
But somebody dissected an orbit, I guess, with an eye in it. It represents, this is cool though, a vestigial nictitating membrane.
What in the world is a nictitating membrane?
So nictitating membrane is a third eyelid that kind of goes from the nose part of your eye to the ear part of your eye.
Ooh.
And it protects, it has a protection and a lubrication kind of function. You can see it. Where I saw it is when I was working with the birds I was working with. The owls had it. And so they would kind of blink without blinking.
Yeah.
And it's the first time you see it, you're like, whoa, what was that? But I think other animals have nictitating membranes. They are made to see through.
Wow. So you can blink without
Right.
like losing vision, without
I think I saw them in sea turtles too when I was, studying those
I want to
with
say
my daughter.
like reptiles in some fashion have something like that.
Yeah. So they can actually blink, but keep their field of vision pretty intact.
So is this just the?
This is the leftovers from that.
Yeah, it's just like this. They rip that out, and that's the little tab that's left, or something.
No, it just kind of becomes smaller and smaller and smaller. Now it's a little membrane that's tucked in the corner of the eye
on the nose side.
Yeah, on the nose side. So by the tear duct. And now if everybody's looking at their eyes right now looking at that, what we call medial, but the nose side of your eye, there's a little fleshy pink triangle. That is not it.
No.
Okay.
Okay.
But it's near there.
Okay.
Okay.
What is the little flat? Do you know what? Was that a question you weren't prepared
It's
for?
the inner canthus.
Oh, wow. Okay.
Yeah.
Is that where? Okay. So what's? Is it adjacent to that? Is it just right there
I
next
think
to
it's
it?
tucked in a little fold, so I think you have to pull your lower lid down.
Oh, okay.
Yeah.
Okay. Is this where sleep comes from?
No, I would think that comes from tear ducts.
Okay. Okay.
Yeah.
That's just crustiness from
Yeah.
dried up tears.
Yeah.
Okay. Okay.
Yeah. So the function of this Pellica semilunaris is lubricating the eye.
Okay,
So it has
okay.
that function. And it does contribute to tear production, but really it's not the main part of the
Okay.
show.
Okay. Wow.
I know, isn't that cool?
That is cool.
So
That
it's
is.
vestigial. You thought just the only vestigial organs were like maybe the coccyx of the spine, which is the lower part of the spine down by people's butts, or the appendix,
Yeah, right.
also vestigial.
Yeah, all these
But
other ones I didn't
we
know.
got all these other weird things that tell
So-
our stories.
So vestigial, does that mean necessarily that at one time in the past the creature that became us had that? Or does that mean that at one time in the past the creature that was us had the ability to develop that?
I think probably both,
Really? Okay.
because that could be in the same creature, right? You have a genetic ability, and then you have actual.
So
So,
e-
that's genotypic, phenotypic, right?
But sure, but so there's such a thing then do you consider as like a vestigial potential?
Yeah, there's probably tons of vestigial potentials.
Things that could have gone a certain way and are just that
Right.
little fork in the road is kind of
Right.
left there and you can see
But
it.
what I think this is a lot of these things were just kind of hitchhikers on another potential.
Right, right.
So we had this potential that was really helpful, evolutionary, and this was just part of the
Yeah,
picture
yeah.
and not really a significant
Sure,
part of
because that's another thing people forget. I mean, everybody thinks about all of this as being so genetics, meaning and evolution, and all of that being so like directed, and it has a task and a mission, and it accomplishes it. It's a mess, and it's
No,
random.
it's
and
totally
It's a
random.
pile of stuff that oozes in all these different directions at one time, and whatever works, right?
Yeah. And if somebody genetically is going left, that means a lot of other things.
Right.
Also, and maybe it wasn't quite as good as it looked in the beginning,
Mm-hmm.
and so you shift in a different direction, kind of. But
Yeah, the intricacy of that is just, I mean, I think our thought process is supposed to, in a lot of analytical senses, to sort of simplify things. And I think we just oversimplify nature just across the board.
right, it also doesn't happen at a speed that is
Right.
real to us.
Yeah.
Although some of it does. Sometimes, there's shifts and drifts, and
Mm-hmm,
sometimes it happens really fast, and sometimes it's
Well, sure. It's the difference
Right,
between a
forever.
continental drift and an earthquake, right? Yeah.
Right, exactly. So, in the last one is kind of one of my favorites. This is a sesamoid bone.
Okay, I'm not even reading it. Sesamoid. I can't
Yeah.
even get up. I'm trying to think of other times moid. I've seen that those
That
words.
means like, sesame-like.
Okay, is that all it says? Sesame like.
So what they are is they're like little random pebble-like bones that are embedded in tendons. And what
Whoa.
they're there for is to change the mechanics of the tendon so that it functions better, but so that it also is protected from damage. Because tendon damage hurts, right?
Is there a specific function that having these little things embedded in the tendon helps with, or is it? Is
Yeah,
it
they
just,
offload the tendons. It's
Offload,
like
what's
a
that
different
mean?
fulcrum.
oh wow, okay,
Does that make sense?
Yeah, but like a
Okay.
bunch of them.
Yeah, you've got, and nobody has, we couldn't x-ray my foot and see the same sesamoid. I might have no sesamoids and you might have some.
Mm-hmm. Wow.
But the ones everybody has are kneecaps.
Okay,
How cool is that?
just like free floating. Is that what this is? Sort
It's
of.
not free floating, it's embedded in tendons.
Okay.
So if you use our kneecap as the most well-known example, the kneecap is anchored by tendons in at least two directions, right? Proximal and distal, so closer and far away. And then kind of in a groove with some of the bones.
Okay.
So it offloads how the knee works. Is the
So-
simplest way to say it.
So okay, yeah, because it strengthens, just reinforces that. When you're saying offloads, mean it takes some of the strain off of
Yeah,
just
it's
the
a
regular
fulcrum.
movement.
It works as a fulcrum.
So-
Now you can have these in your feet, is where I see them. That you can also have them in your hands. Probably Probably near your wrists, I would think. And they're about, when I see them on X-ray, they look like pea-sized usually.
Wow.
Yeah, the patella
Wow.
or the one in your kneecap is huge compared to the little random ones we have everywhere.
So in development, like a kid will have, like you mentioned, wrists and feet. You'll have like bones won't be joined when they're younger,
No.
right? Is that kind of the similar sort of situation?
Yeah, that's probably when they develop. We need a little something here.
Mm-hmm. Okay.
So here's our handy sesame. Boom.
Wow,
Plop.
that's really neat.
I know, isn't it cool? But when you look at them on X-rays, it alarms people because they're like, "That's a fracture.
It's going to break off and it's going to go to my brain.
I'm like, "No, it's not a fracture. It's not a fracture. It's just a random little bone. Nobody cares."
That's really interesting. Wow.
Yeah, I thought that was interesting too, and I also think it's funny what they chose to name it. It looks like a little random sesame seed.
I know, it's like,
Yeah.
a scientific word for it just looks like a sesame seed. That's great. Wow,
Well, there
and
was no old white guy.
Yeah.
to name it after that day.
you couldn't drag somebody up like Darwin from the past, like Freud, some other
but
old
we
white
don't know
guy.
if it's that Darwin. So
That's right. I'm just assuming.
more than one
I'm
Darwin.
just assuming.
Maybe he had a brilliant anatomist cousin who was a physician. Anyway.
No, not that Darwin.
Yeah.
Oh my gosh, thank you. That was a really fun topic.
Yeah,
Lynn.
that was kind of interesting, huh? So I spent the whole week going, "Oh, there's like 20 more things. There could be a second show on this."
Okay, hold on to that.
I think we are so beautifully put together and so kind of randomly. It's kind of a miracle that we function as well as we can most of the time.
There's something about like the whole intelligent design thing, right? Because you look at the human body and it's not efficient in design. I mean, how can I say this? Its design is not, when you look at it, you see all these vestigial things and you
Right.
see the time and the journey it took for us to get here.
Right.
It doesn't seem like, it seems so chaotic. It doesn't seem like some sort of intelligent design. A creator sat down and mapped out the perfect human. No, we are just accident upon accident upon accident
Right.
reacting to itself.
Right. It's like somebody's elderly grandfather in the basement throwing tools around.
Yeah, and hopefully
Oh, I
building
got
something.
just the thing for that. No, it's too big.
That's good. That's a good analogy. I like that.
it seems totally random. And then the beauty of how these sweet little design flaws, can you call them that, or just sweet little residual designs
Yeah.
are, and when you find them and you understand what they are, it's just sweet.
Sweet. What do you mean?
Yeah.
How do you mean sweet?
I think it's a beauty. I think it's part of the beauty of the body.
Right.
So, I was going to mention this last week, but when I was in school, I didn't sleep a lot because there was a lot to do in PA school. And once I didn't sleep for 3 days and I started hallucinating.
Uh-huh.
And so I hallucinated myself as the molecule in the Krebs cycle. And not at all alarmed by this, although luckily my roommate just just kind of watched me until it was done. But what I gained from that, the whole point of this story is the beauty, even on a molecular level, of how things all work together.
Right.
Despite how they were created. And numerous levels of creation. There's evolutionary, and there's genetic, and there's developmental and embryologic, and all that kind of stuff. To make a human that gets through the day, I think is astonishingly beautiful.
Yeah. No, I can totally agree. Yeah.
Yeah, it was the first time I understood the Krebs cycle, but my understanding was only limited to...
It was in the first person.
Yeah, I know. I was like, whoa, is that an electron? It was so trippy. So, but there is a great deal of beauty. Anyway.
Thank you, Lynn. Thank you very much. That's wonderful.
So I just want to mention new staff at Del Norte Community Health Center and a new PA at UIHS. So if you're looking for providers in those two institutions, help has arrived.
Wonderful. That's such good news.
Super exciting. And you're going to see high presence with Dr. Turner in the homeless clinic and the mobile medical, which will mostly be parked in the Del Norte Community Health Center parking lot with the showers. So the showers are the draw, and hopefully Dr. Turner can continue his great practice
Wonderful.
with people who need it.
All right, Lynn, thank you so very much. Any thoughts about next week's Health Matters?
No.
No, we'll
actually.
just see what happens.
We'll see what happens.
Okay, all right. Thank you very much.
Uh-huh.